In the previous lecture, we had seen the Twiddle factor matrix, how to compute the Twiddle factor matrix. So if you want to compute a 4 by 4 matrix, okay, so here the value of small n ranges from 0 to 3 and the value of k ranges from 0 to 3. So you can compute the 4 by 4 matrix, and this is a W4 Twiddle factor because we are computing the 4-point matrix. So this is W4, and then you can go on writing the values. So W40, 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 and here in the second row we are having W40, 1, 2, 3. Third row we are having 0, 2, 4, 6. Fourth row we are having 0, 3, 6, 9. So when you compute all these values with the help of the Euler's identity and you substitute in this matrix, so you get this matrix. This matrix is called as the Twiddle factor matrix. Now using this Twiddle factor matrix, we can compute the 4-point DFT. So what we have to do, this capital XN denotes the DFT of the sequence, and here this is the Twiddle factor matrix. This is the given sequence. So the given sequence is 1, 1, 0, 0. So I use the matrix multiplication, multiply this. So after multiplying this matrix, after multiplying these two matrices, I will get the DFT of the sequence. Now we can compute the IDFT also using the matrix method. Now, what is the formula for computing the IDFT with the help of matrix method? So in this case, xn denotes the IDFT. So here capital N is the number of point of DFT. Here we are having the matrix called as Wn star. So this star indicates that it is a conjugate of this. So in signal, this star here asterisk symbol indicates that Wn, we have to take the conjugate of Wnk. See, Wnk is actually a complex number. You can see here. Here it is minus j, j, and minus j. So when you take the complex conjugate of this, so whatever the values of this imaginary part is there, it will change. The real parts, the sign will remain same. So here it is minus j. So minus j will become plus j. J will become minus j, and this j will become minus j, and this minus j will become plus j. So only thing change is here that only our sign of the imaginary part changes, others will remain the same. So it is very easy to compute the Twiddle factor conjugate. Important thing is computation of Twiddle factor matrix. So once you understand this computation of Twiddle factor matrix, you can easily get the conjugate of the Twiddle factor matrix. And next what you have to do, we have to multiply matrix multiplication of the Twiddle factor matrix with the given DFT. So this is the given DFT. So in this numerical we are given the DFT as 2, 1 minus j, 0 and 1 plus j. Now just multiply these two DFTs, multiply these two matrices by matrix multiplication, and you can get the original sequence. So here in this way we can use the matrix multiplication method to compute the IDFT. So in this only two steps we can get the answer. So there is no need of so much computations which we had seen in the previous numericals, where we have to compute the so many calculations are required there. But here in case of matrix method, the number of calculations are very less, because we are making use of the Twiddle factor matrix. So one thing, important thing to note down here is that, so when you are computing the DFT, you have to use the Twiddle factor matrix directly, but when you are computing the IDFT, you have to use the conjugate of the Twiddle factor matrix. And here you have to divide by n. Here you do not, in case of IDFT, you have to divide by n. So 1 upon n. So final answer will be divided by 1 upon n. Final answer will be divided by 1 upon n. But in case of DFT, it will not be divided. It will be just a simple multiplication. So these are the two slight differences which we can understand from the formula. An important thing is computation of this matrix, which is called as a Twiddle factor matrix. So you have to practice to compute these values of the Twiddle factor matrix from the given matrix. So given matrix. So normally in exam 4 by 4 matrix is asked. We will not go for 8 by 8 matrix. Similarly, you can compute a 8 by 8 matrix. K value will range from 0 to 7, n value will range from 0 to 7, but that will become a very huge matrix, so that we are not having it in exams. So that's why we are not going to see about the 8 by 8 matrix. Similarly, we can have 16 by 16, 32 by 32 and so on. but 4 by 4 matrix is sufficient for understanding. Once you understand 4 by 4 matrix, you can solve for any type of matrix, whether it be 8 by 8, 64 by 64, or 1028 by 1028. So in this way, understand the formulas and try to solve by using the matrix method. Try to understand how the conjugates are taken, how the matrix multiplication is done. I hope everybody understands the matrix multiplication. Here it is 2 into 1 plus 1 into this, then 1 into 0 plus 1 into this. All these values when you add, you'll get the first element. Similarly, you multiply this row by this entire column, you'll get the second value. Multiply this third row with this entire column, you'll get the third value, and multiply this fourth row with this column with this entire elements, you will get the fourth element. So in this way, by doing the matrix multiplication, you can get the values of DFT and IDFT directly. So matrix method is a popular method because the number of calculations required is less, the number of steps is less, so the possibility of making mistakes here is less compared to the traditional method, wherein we have to compute the values by substituting the values n and k and do a lot of calculations. So this is how we compute the DFT and IDFT using matrix method.